In this class, now I am going to evaluate integrals of 6 functions, so which are very useful while doing applications. You can remember like a standard results. Now let us see those functions. Integral of 1 by square root of a square minus x square dx. So if you evaluate this function integral, you will get sine inverse of x by a plus c. Okay students, how we will get this integral of this function as this? I will give you proof. Now here the substitution is x equal to a sin theta. So this is also called as an irrational function. See, I am going to evaluate whose integral by substitution. So here the substitution is x equal to a sin theta. You know, make sin theta as subject, you get x by a. Make theta as subject, sin inverse of x by a. Okay students, now do the derivative on both sides with respect to x, so that here x derivative is 1, a into sin theta, derivative cos theta, d theta by dx. Now make dx as subject, so that you will get a cos theta d theta. Okay students, so in the place of dx write this value. After getting the result, at the end in the place of theta write sin inverse of x by a. Keep it aside. Okay, right. Now see, integral of, in the place of dx write this value, a cos theta d theta by square root of a square minus x square. So here a square sin square theta. Now simplify that. If you simplify this, so take a square outside. Okay, so that a will be going to cancel with numerator a. So in the numerator cos theta will be left, in the denominator square root of 1 minus sin square theta. In the place of 1 minus sin square theta write cos square theta, square root is there, cancel. Cos theta will be left to d theta. Both of them cancel. 1 into d theta will be left. As you know, integral of 1 d theta is theta plus c. So theta is equal to sin inverse of x by a plus c. Okay students, see, let us see one small example based on this. Integral of 1 by square root of 16 minus 9x square dx. If a function is given like this, so how you people have to answer this? Integral of 1 by square root of, so here 16, this 9x square you can take as 3x whole square dx. So let us take 3x equal to t. Now do the derivative on both sides with respect to x. 3 equal to dt by dx. Now dx equal to dt by 3 you will get. Now come here, integral of dx value is dt by 3 whole by 16 can be written as 4 square minus, so 3x is t square. Okay students, now 1 by 3, so integral of this value is sin inverse of t by 4 plus c. So 1 by 3 sin inverse of t value, so 3x by 4 plus c. Like that you people have to evaluate integral of this kind of functions. Okay students, right. So suppose if a function is given like this, how you have to evaluate it? 1 by square root of a square plus x square dx. What is the difference between the previous one and this one? In the previous one, in the middle I kept minus, here plus. If plus is given, the substitution is x equal to a sin h theta. X equal to a sin h theta. Now do the derivative on both sides with respect to x, so that you will get here x equal to a cos h theta d theta by dx. Okay students, here it is going to be 1. Now make dx as subject, so that you will get a cos h theta d theta you will get. Now in the place of dx, write this. You get cos h theta d theta whole by root of a square plus, in the place of x write this, so that it will become a square sin h square theta. So now simplify this. In the numerator it is going to be a cos h theta. In the denominator take a square outside. If it a square is outside, so inside square root of 1 plus sin h square theta will come. That is nothing but cos h square theta. You know, in the hyperbolic trigonometric functions, cos h square theta is equal to 1 plus sin h square theta. By this identity, denominator is going to be cos h theta d theta. Both of them cancel, 1 into d theta. So 1 value, see, theta plus c. Here what is theta, students? See here, transfer x a to the left side, so that you get sin h theta is equal to x by a. Theta is equal to sin h inverse of x by a. So write this value here, sin h inverse of x by a plus c. You know, the sin h inverse of x by a in terms of log also you can write. If you express in terms of log, you will get a log of x plus root of x square plus a square plus c. Sin h inverse of x by a can be expressed in terms of logs. So you will get log of x plus root of x square plus a square. Okay students? See, now let us go for one more function. See this, integral of 1 by square root of x square minus a square dx. Observe the previous two and this one. Here first variable, next constant is getting. So in this case follow the same procedure. Here substitution is x equal to a cos h theta. Follow the same procedure. At the end you will get cos h inverse of x by a plus c. If you want to express this one in terms of logs, you will get log of x plus root of x square minus a square plus c you will get in terms of logs. Okay students? Right. Now remember, like a standard results which helps you while doing applications. Now let us discuss 3 more formulas. Observe the previous 3 and these 3. So integral of here a square minus x square dx and integral of root of a square plus x square dx, integral of root of x square minus a square dx. I will write these 3 formulas here and I will give you proof of this first one, and remaining 2 you try by yourself. Same procedure. Okay students, if you want I can give you this one and this one. This you try by yourself. See the results of these 3 integrals. X into root of a square minus x square by 2 plus a square by 2 sin inverse of x by a plus c. This one x into root of a square plus x square by 2 plus a square by 2 sin h inverse of x by a plus c. This one x into root of a square, x square minus a square by 2, here middle minus will come for this, a square by 2 cos h inverse of x by a plus c. Integral of root a square minus x square dx. Result would be x into root a square minus x square by 2 plus a square by 2 sin inverse of x by a. Observe these three. Here x by 2, here x by 2, x by 2. Whichever you got here, same should be written here. Same. In the middle, a square by 2, a square by 2, a square by 2. Plus here minus. Here sin inverse of x by a. What about these two? Here sin h inverse of x by a, cos h inverse of x by a. In the previous three also, whenever these were given in the denominator place, same functions were repeated. Am I right? But here, previous three we took reciprocal. So that those functions became like this. Whenever the functions are given like this, you people have to use the standard results. Okay students, I will give you proof of these two and this you try. See the first one. See, what is the substitution here? X equal to a sin theta. Now, at the end what do you get? Theta is equal to sin inverse of x by a. So now do the derivative on both sides with respect to x. Here it is going to be 1. Here it is a cos theta d theta by dx. Now dx equal to a cos theta d theta. Okay, now go here. Integral of a square minus x square. So here a square sin square theta. Now this is dx. In the place of dx write a cos theta d theta. From the square root to take a square outside, which will come as a. This a into this a becomes a square. Keep it outside. Here what do you get, amma? 1 minus sin square theta will be left. That can be written as cos square theta. Square root to cancel. Cos theta into cos theta. Cos square theta d theta. Okay students, right? In the next step, what you have to do? So this has to be written as integral of 1 plus cos 2 theta by 2. Shall we write? Yes. We learned that formula in the multiples of trigonometric ratios. Use that formula to evaluate whose integral. Now there are two terms. So separate those two terms. A square by 2 1 into d theta plus, students, here what do you get? A square by 2 integral of cos 2 theta d theta. Here whose integral is theta. And here a square by 2 integral of cos 2 theta sin 2 theta by 2 plus c. Now here theta value, as you know, sin inverse of x by a. So here a square by 2 2s are 4. The sin 2 theta can be written as 2 sin theta cos theta plus c. 2 1s are 2 2s are. Okay, cancel this 4 with 2. So that you will get, see, what do you get? A square by 2 sin inverse of x by a plus 2 1s are 2 2s are. Now a square by 2 sin theta. In the beginning itself you got as x by a. Am I right? And cos theta will be, so cos theta you can write as 1 minus sin square theta. So in the place of sin theta write this x by a. So x square by a square. On simplifying this you will get a square minus x square by a. Root of a square minus x square by a plus c. Okay. Now you have got your required result. See here. So this a square cancel. So x into root of a square minus x square by 2 plus a square by 2 sin inverse of x by a plus c. So this is your required result for that given integral. See, they may give you the problem like this. Integral of 16 minus 9x square dx. How do you evaluate this? See, this has to be written integral of 16 minus 3x whole square dx. In the next step, 3x equal to t you have to take. Now, 3 equal to dt by dx. Now, your dx will be dt by 3. Now, come here. Integral of 16 minus 3x value, we took as t na t square and dt by 3. By 3, I am writing in the beginning itself. Now, we have transformed the given one into our formula. So, hereafter, apply this formula. So, wherever a is there you have to write this 4. And wherever x square is there you can take t square. Okay, just simply this a square minus x square here, and at the end of the solution, in the place of t, write this 3x. Okay, students, shall I write complete solution? See here, x value is how much here? T. So t into root 16 minus t square by 2 you will get, plus a square value 16 by 2 sin inverse of x by a, x value t by a value 4 plus c. Okay, students, now in the place of t write 3x. Okay, because we assumed t as 3x na, right here 3x square root of 16 minus 9x square by 2 plus 8 sin inverse of 3x by 4 plus c. Like this you people have to evaluate integral of this function. Okay, students, right. Next, one more. See this integral of a square plus x square. This proof also same like previous one, but here we have to take x equal to hyperbolic trigonometric function. A sin h theta is the substitution. Now do the derivative on both sides. You get a cos h theta d theta by dx. Now your dx will be a cos h theta d theta. Now make theta as subject. On making theta as subject, you get as theta equal to sin h inverse of x by a. Okay. Now come here and simplify. A square plus x square means in the place of x you have to write this. A square sin h square theta and dx value a cos h theta d theta. Now simplify this. So this a will become a square. Inside 1 plus sin h square theta is nothing but cos h square theta, square cancel, cos h theta into cos h theta, cos h square theta d theta. Okay, amma. Right. Cos h square theta. How you have to write? You have to see, convert into the multiples formulas. So you learned this formula in the multiples chapter. Cos h2 theta in terms of sign you can write like this: 1 plus 2 sin h square theta. Am I right, students? So cos h2 theta can be written as 1 plus 2 sin h square theta, but here we have cos h square theta na? Yes, cos h square theta. We want this result in terms of cos h theta. So in terms of cos h theta, 2 cos h square theta minus 1. Okay, in the next proof, x square minus a square is there na? There we have to take substitution x equal to a cos h theta. Okay, in that simplification, here in the simplification part you will get sin h square theta. There you have to use this formula. 1 plus 2 sin h square theta. Okay students, cos h2 theta can be written as 2 cos h square theta minus 1 plus 2 sin h square theta. But in the basic trigonometry, here you will get minus sign. But in the hyperbola, you will get plus sign. Remember that point. Very useful relation. So here, what you have to write? In the place of cos h square theta, cos h square theta can be written as 1 plus cos h2 theta by 2. See, what do you get on writing this one over there? A square integral of 1 plus cos h2 theta by 2 into d theta. Right. Now a square by 2 integral of 1 d theta. What about this 1 by 2 integral of a square by 2 cos h2 theta d theta. Integrate it. So here you will get a square by 2 theta, and here a square by 2 cos h2 theta integration will be sin h2 theta by 2 plus c. So your theta will be how much? Students, tell me. Sin h inverse of x by a plus a square by 4. This sin h2 theta can be written as 2 sin h theta into cos h theta plus c. Okay students, right here 2 ones are 2 twos are you will get. So what do you get here? A square by 2 sin h inverse of x by a plus a square by 2. This can be written as x by a. So this can be written as root of a square plus x square by a you will get, students. Because as you know, cos h theta can be written as 1 plus sin h square theta. Am I right, students? So here sin h theta value x by a. X by a if you write and if you simplify you will get root of a square plus x square by a you will get. So in place of this I wrote x by a. In place of this I wrote root a square plus x square by a. Okay, this a square cancel. So at last what you people are getting, students, see here a square cancel, x will be left, x into root of a square plus x square by 2 plus a square by 2 sin h inverse of x by a plus c. I hope you have understood this. So in sometimes in the options they may write in place of sin h inverse of x by a as log of x plus root of x square plus a square. This also they may give you. You know, in the hyperbolic trigonometric functions, sin h inverse of x by a can be written like this. Here if cos h inverse of x by a is given, just here middle minus will come. Okay students. So one more integral is left. So I wrote just a formula. You people can try use proof. Otherwise remember like a standard results. So in this class I taught to you 6 integrals. And whose proofs also I gave you. And you better to remember like a standard results which helps you while doing the applications. Thank you students. Thank you one and all.